Today we are going to integrate this expression 1 over x plus square root of 1 minus x square with respect to x. So when we look at this expression, we see square root 1 minus x square, which is the problematic part. And we see a fraction 1 over something. And we see two terms in the denominator. So my instinct whenever I see a fraction and the denominator has two terms, my instinct is to rationalize that expression. So I tried multiplying this expression with x minus square root of 1 minus x square. I tried to rationalize this, but it failed. I also tried substituting for this square root of 1 minus x square, and that failed too. So when both of those methods failed, I had to come up with something different to solve this question. And when I looked at this expression square root of 1 minus x square, I saw this 1 minus x square, and 1 minus x square is basically, when we look at this expression square root of 1 minus x square, this comes in the derivative of sine inverse of x and cos inverse of x also. So this basically gives us a hint that you can use trigonometric substitution here. So I used trigonometric substitution, and it worked out. So we are letting x is equal to sine theta, and when we take the derivative of, because we want this expression in the form of theta now, so we also need to replace this dx with a value in terms of theta. So we need to take the derivative of this x, because we want to replace dx with some value. So dx is going to come by taking the derivative. So taking the derivative of this equation with respect to theta on both sides, and we get dx over d theta. And on the right side, when we take the derivative of sine theta with respect to theta, we get cos theta simply. And we want the value of dx in terms of theta. So we cross multiply, we get dx is equal to cos theta d theta. So this is the value of dx in terms of theta, and we are calling x sine theta, or I should say we are calling sine theta as x. So this becomes integral of 1 over sine theta, because x is sine theta, plus square root of 1 minus x square. So for x square we need to square this equation, and we get x square is equal to sine square theta. So 1 minus sine square theta, and dx has the value cos theta d theta. So cos theta d theta. So this becomes integral of 1 over sine theta plus 1 minus sine square theta is equal to cos square theta. From the identity, sine square theta plus cos square theta equal to 1. And square root cancel out, and cos theta d theta is written as it is. So this becomes 1 over sine theta plus cos theta times cos theta d theta. This cos theta can be multiplied this with this one. So cos theta over sine theta plus cos theta, and we are integrating this with respect to theta. So now we have a fraction, and we need to integrate it. So as I told you earlier, that my instinct whenever I encounter a fraction and I am integrating it and it has two terms in the denominator, my instinct is to just rationalize it, multiply and divide it with the somewhat conjugate of the denominator. So sine theta plus cos theta. So sine theta plus cos theta, and I am multiplying this fraction with multiplying and dividing this fraction with sine theta minus cos theta, because when we multiply the given multiply our expression with some value, we also need to divide it by some value. So I multiplied this expression with sine theta minus cos theta, so I also need to divide it by sine theta minus cos theta, because these two cancel out to give us the original expression. So this is called rationalization. So next we multiplied this cos theta with sine theta minus cos theta, and we get cos theta times sine theta minus cos theta, and in the denominator we have a plus b into a minus b, which is equal to a square minus b square. If you multiply a plus b into a with a minus b, you get a square minus b square. So here a is sine theta and b is cos theta, so in the denominator we'll get sine square theta minus cos square theta. And in the next step, the numerator remains same. Cos theta is being multiplied with this sine theta minus cos theta, so it will become cos theta sine theta minus cos theta into cos theta is cos square theta. Sine square theta minus cos square theta, I've written this in the form of cos square I've written this cos square theta in the form of sine square theta. So cos square theta is equal to 1 minus sine square theta. So cos theta sine theta minus cos square theta, and that negative sign, when we multiply it with 1 minus sine square theta, we get minus 1 plus sine square theta. So in the denominator it becomes 2 sine square theta minus 1, numerator remains same. The numerator remains same and the denominator is 2 sine square theta minus 1. Now we can see that in the numerator we have a term which is cos theta sine theta. It resembles a formula, and it resembles the formula of sine 2 theta, which is equal to 2 sine theta cos theta, but we have just cos theta sine theta here, so we need to multiply it with 2 to make it sine 2 theta. And to do that we have to multiply this whole numerator with 2, and if we are doing that to the numerator, we also need to do that to the denominator to balance it out. So we are multiplying and dividing with 2, so this becomes 2 times cos theta sine theta minus cos square theta over 2 times 2 sine square theta minus 1 with respect, and we are integrating this with respect to theta. So this becomes 2 cos theta sine theta minus 2 cos square theta over 2 times 2 sine square theta is 4 sine square theta minus 2 ones are 2. So the problem here is that the denominator basically has two terms, and we can't really use the linearity property of integration if we can't separate these terms of numerator. And why we can't separate these terms or write these terms in the form of fractions? Because we have two terms in the denominator. We need to have a single term in the denominator so we can separate these numerator terms in the form of fractions, and then we can apply the linearity property. So the next step which I did was to use the formula of cos square theta and sin square theta. And cos theta is basically square root of 1 plus cos 2 theta over 2. This is the formula, half angle formula, where the half angle is converted into the double angle. Theta is being converted to 2 theta. And when we want the value of 2 cos square theta. So firstly, we need to find the value of cos square theta. When we find for us to find cos square theta, we need to take the square of both sides. So it becomes cos square theta equal to 1 plus cos 2 theta over 2 whole square. So square and square root cancel out, and we are left with cos square theta equal to 1 plus cos 2 theta over 2. We are interested in 2 cos square theta, so we need to multiply this with 2 on both sides. So left side becomes 2 cos square theta, and right side becomes 2 times 1 plus cos 2 theta over 2. 2 and 2 cancel out, so 2 cos square theta has value 1 plus cos 2 theta. So we have gotten the value of 2 cos square theta. Now we will find the value of 4 sin square theta. And the formula for sine is similar to that of cos theta, but it just has a negative sign in the numerator here. In cos theta we have plus, and in sin theta we have minus here. So sin theta is basically square root of 1 minus cos 2 theta over 2. This angle here is again the double of this angle. So when we take the square, we get sin square theta equal to 1 minus cos 2 theta over 2, and we are interested in 4 sin square theta, so we'll multiply both sides by 4. So we get 4 sin square theta equal to 4 times 1 minus cos 2 theta over 2, and this becomes 4 sin square theta equal to 2 times 1 minus cos 2 theta. So we now have both values, the required ones. 2 cos square theta is equal to 1 plus cos 2 theta, and 4 sin square theta equal to 2 times 1 minus cos 2 theta. We'll plug in both of these values to see what happens. So sin 2 theta, I told you that this has become the formula for sin 2 theta now. So sin 2 theta minus times this had value 1 plus cos 2 theta, and this had value 2 times 1 minus cos 2 theta minus 2 is that as it is. So sin 2 theta, this negative is distributed. It becomes minus 1 minus cos 2 theta over this 2 is being multiplied with this expression. So this becomes 2 minus 2 cos 2 theta minus 2, 2 and negative 2 cancel out. So now we have the, our desired expression, because in the numerator we just have one term, and this will help us in using or exploiting the linearity property of the integration. So this negative sign, I'm moving it outside the integral, and the expression becomes sin 2 theta minus cos 2 theta minus 1 over 2 cos 2 theta, and we are integrating this with respect to theta. So our expression becomes, in the numerator we have now 3 terms. As you can see here, that in the numerator I have 3 terms: sin 2 theta minus cos 2 theta minus 1 over 2 cos 2 theta. So I'll just separate these terms in the form of fractions. I'll write sin 2 theta over 2 cos 2 theta, and I'll integrate it separately, minus cos 2 theta over 2 cos 2 theta, I'll integrate that separately, and finally 1 over 2 cos 2 theta, and I'll integrate that separately. So we are basically using the linearity property here. So this is what we get after using the linearity property: negative times integral of sin 2 theta over 2 cos 2 theta d theta minus integral of cos 2 theta over 2 cos 2 theta, and we are integrating this with respect to theta, minus the integral of 1 over 2 cos 2 theta and we are integrating this with respect to theta. So this becomes negative times integration of sine 2 theta over 2 cos 2 theta d theta minus cos 2 theta and cos 2 theta, they cancel out. So this becomes integration of 1 over 2, and we are integrating this with respect to theta, minus the integration of 1 over 2 cos 2 theta, and we are integrating this with respect to theta. So our integral has now become a combination of these three integrals, and we need to evaluate these three integrals to find the final solution. We'll do that in the next video. For now, I'm doing this integral up to this point.